All right, we're doing still the rational function, but we're doing the story problems. Okay, and so when there's three types of story problems, and they all deal with mixtures. Okay, and these are the ones that they love to put on the ACT. The first mixture problem is when you have in chemistry, when you have amounts of an acid or a chemical. Okay, so you just have to read the parts of it. So this says, if you look at this, it says you have 70% acid to 12. Oh, wait, no, I don't want that. I already saw that. So it says, Mia adds 70% acid to 12 milliliters of a solution that is 15% acid. So that goes together. So you're mixing the pink and the blue, and you're getting it to equal how much of the 70% acid should be added to create a solution that is 60%. Okay, so what you're doing is you're taking this pink amount, okay, and this is 70% acid, and you're mixing it together with the green amount, which you actually know a couple of things. You know it's 12 milliliters, and you know it's 15% acid. Okay, and in the end, you want that to equal an amount that is 60% acid. So if you just even use common sense, because sometimes that's half the battle in math is to use common sense, you know your answer is going to have to be a lot bigger than 12 milliliters because you're only turning it in to 60%. And so you're at 15%, you're not going to dump a ton of the 70% in to make the 15%. Okay, so what we're really looking for on this problem is we're looking for how many liters, right? How much of the 70% acid, would we add? Okay, that's what we're looking for, is we're looking for that amount. So if I do 0.7 times x plus 0.12 times, or sorry, that's 0.15 because that's my percentage, 0.15 times 12 equals, now when I dump them together, aren't I going to have x plus 12? Because it's a mixture problem, and so I'm going to have 60% of that. So if I take out my calculator and I do all this math, I actually did it on paper, to save me a little bit of time here, I would have 0.7 plus 1.8 equals 0.6x plus 7.2 when I times that in. So if I move my 0.6 this way, I'd have 0.1x, which means I'm going to minus my 1.8, and that's going to equal 5.4. So I'm going to divide by 0.1, divide by 0.1, and my answer is 54 milliliters. And this is what I would have done, I just even using common sense. I knew it was going to be a lot bigger than 12 milliliters because I want it 60%. So I'm going to have a lot more of the 70% when I mix it together. So this is one type of mixture problem, a mixture problem when you are dealing with chemicals or something from chemistry. Okay, example 10. It says Sandra is rowing on a canoe on Stanhope Lake. Her rate in still water, so this is important, still water is 6 miles per hour. It takes Sandra 3 hours to travel 10 miles round trip. So it takes 3 hours to travel a total of 10 miles round trip. So that would mean 5 miles there and 5 miles back. Assuming Sandra rode at a constant rate of speed, determine the rate of the current. So my final question on this is to determine the rate of the current. Okay, so I do know something. I do know that this took me a total of 3 hours. And I know distance equals rate times time. So wouldn't my time be distance over rate? So I know that in still water it's 6 miles per hour and it's a 10-mile round trip. So I'm going to go 5 of those miles, and the water is going to be making me go faster. The current is going to be going against me or with me and pushing me faster. But then aren't I going to be going 5 of those miles where it's working against me and slowing me down? Okay, so if I look at this, I can solve this by finding my LCM. So my LCM on this problem would be 6 plus R, 6 minus R. So I'm going to do times each of them by 6 plus R, 6 minus R, 6 plus R, 6 minus R, 6 plus R, 6 minus R. So the first one, the 6 plus R would cancel, and so I'd have 30 minus 5R. The 6 minus R would cancel, and so I would have 30 plus 5R. Okay, and then on this last one, I'm going to go ahead and just FOIL this. Wouldn't that be 36 minus 6R plus 6R minus R squared? So then I'm timesing that by 3. So 36 times 3 is 108. So that's 108 minus 3R squared. So if I look, I need to put all my like terms together and get everything on one side because I have a squared. So I'm going to have I'm going to actually move it the other way because then it would become positive. So I'm going to move everything this way because then I have positive. So I'd have 3R squared. Then I have a minus 5R and a plus 5R, so those cancel. And then I have 30 plus 30 minus 108 because I'm going to bring that over this way. And I get a negative 48 equals 0. So from here, I could factor out a 3. So wouldn't that give me R minus 4, R plus 4? So if I solve this, I'm saying that the rate of the current is 4, and this one is saying a negative 4 because it's working 4 with me and 4 against me. So the rate of the current is going to be 4 miles per hour. This is the rate of the current. Oh, that's an E. Okay, and so it's a matter of taking what we know and putting it together. So this is a mixture problem with distance, rate, and time. And so it depends on what they give you, but since the key to this one, honestly, if I mark it with green, just so you can see, the key is 10 miles round trip, which means I'm going 5 there and 5 back. If it wouldn't have said round trip, I wouldn't have known how many miles of each direction. Okay? All right, so every year, the junior and senior class at Hillcrest High School build a house for the community. If it takes the senior class takes 24 days to complete a house. And if they work 18 days, if they work with the junior class. Then the question is asking, how long would it take the junior class to complete it if they worked alone? So we don't know the junior class's rate, but we know the senior class is building one house in 24 days. And we know the junior class is building one house in J days, because I'm just that's my junior class. And we know, right, that together, when you add those two things together, they're completing one house together in 18 days. Okay, so this should do it for us, but we got to find a LCM. So if we find an LCM, I would do 24 times 2 is 48. Does 18 go into 48? No, can't do math today. So I would do 24 times 3. Does 18 go into 72? I believe so. 4 times. So my LCM is 72J. So I'm going to take everything and I'm going to times by 72J. 72J, 72J. So 24 goes into 72J 3 times. So this is going to be 3J. The J's would cancel, so I'd have plus 72. And 18 goes into 72 4 times, 4J. So then I'm going to minus the J, and I get 1J is 72 days. So the juniors take 72 days to build a house. The seniors take 24 days to build a house, and together they can build a house in 18 days. So these are the different types of mixture problems that you will see.